an undeniable benefit of the times we're in. If you're watching this long after it's been recorded, you probably remember the pandemic of 2020. Anyways, the whole point from this perspective is that people are staying at home, which means a lot of more home projects are being done. In my case, I've had this weather station up outside, clearly, for a long time, probably 5-6 years, and it's seen better days. Probably not clear, but this here is supposed to be the cup anemometer thing, which measures wind speed. It's missing the cup things, and just in general, the plastic of this thing has become very brittle. Like, even if I... Well, of course, now it's not going to break. But anyways, it's not working anymore. The wind direction actually does still work, but this is broken. There's no way to get a replacement part. In the 5-6 years since I put this up, the neighbor's tree actually grew, and as they do. And it turns out when trees have like leaves and stuff, they start blocking the wind, so not in a good spot anyways. And it turns out I don't really have a good spot. So, before I toss it, because it's in no good shape to begin with, let's open it up and see how it works, and see if there are any surprises. So, let's go. Oh yeah, it's the Weather Channel LaCross technology model TX23U. That matters to anybody? Probably not. Well, like I said, this thing I've actually, well, first off, I've taken out a few of the screws already because I didn't want to spend too much time on that. And again, clearly it's broken, so, and I'm not going to fix it. It's not an easy thing to fix, so. And even if I did, it wouldn't work because of that tree. I like the tree, so it's either this or the tree. The answer is this. So, let's pull that open. Okay. Ooh, okay. Well, that's interesting. Very interesting. Okay. We've got something here. Something interesting. All right. So, as you can see, we have two pieces here. Let's focus on the weather vane part. Now, as it turns, you can see that there are these slots, and they're in a rather marked pattern. And what that is that is how this guy determines what direction the wind vane is pointing in. If you look at the side, it's actually marked. So when you mount this thing, you're supposed to make sure that this N is pointing north. And that's how the weather vane knows which way it's pointing. I guess this is how I expected it to be done. I'm glad to see... Okay, so how are they doing it? Well, you see these slots here? Well, if you look over here on this guy, you can see that there are 4 what appear to be... Well, they look like LEDs, but what they are actually are photodiodes. Why do I say that? Because if you look here, there is an LED. My guess would probably be an IR LED. It's not really important which one it is. I think you can see that. But what is interesting is how this is done, and that's with this little piece that fell off. This is a light pipe, and it is meant to be placed over the LED, so I can probably get it. Whatever, it's in there good enough. Ah, there we go. So how this works is actually pretty clever. The LED puts light into this light pipe, which projects light downwards, which is then blocked selectively. Each of the 4 receivers are blocked selectively by these slots, and by that combination, there's an encoding here. You can determine which way the weather vane is pointing. So that's very clever. I like that. So The old way of doing something like this, perhaps, there's a few ways you could do it. You could use a potentiometer. That's an analog way of doing this, which would work fine. Or you could do it just with sliding contacts on traces, which would also work fine. But the problem with both of those solutions is that it's a mechanical connection, a mechanical electrical connection, right? You've got sliders on traces or sliders on a resistive material of a potentiometer. That's prone, one, to wearing out, and you can imagine this vane is going to be going back and forth a lot over years, and two, it's not the most weather tolerant way of doing things, right? If this thing gets slightly moist inside, which it will, no matter how well you seal something, moisture will always get in, past the bearing shaft, whatever it might be, that will corrode contacts. This is contactless. It's optical. I like that. That's it's very smooth. I like the light pipe idea. Instead of using, multiple LEDs or something like that, it uses this light pipe. So that's it's pretty clever. I like that. All right, so we've solved the mystery of the weather vane. How about speed of wind? And I can't say that word properly, so I'm not going to try. Anyways, this is supposed to spin. There's supposed to be little cups on here. Cups are missing. So, my guess, based on some other hardware I've seen from this company, LaCross, they make a lot of these sorts of things. I'm guessing they're doing this with magnets. Let's find out. Yeah. So again, I've removed some of the screws ahead of time so that we don't have to waste time. There's just one here. Come on. Okay. There's the screw. Alright. Let's pull this out. It's going to pop out, or is this holding it in? Yeah. Pretty sure it just comes out. Yeah, it just comes out. Okay, so what do we have here? Huh. Okay. Wow. All right. Let's just start with my guess. Magnets. The answer is yes. It does use magnets. And the reason I say that is this guy here is a magnetic reed switch, which tells me that somewhere on this turny bit, it's not inside, just see a sleeve bearing, so there must be something in here. This must pop off, or okay, I don't care about breaking it further. Yeah, there you go. So that right there, I'll zoom in. That right there is a magnet. So what this does, very simply, is this is placed on here, and it's fully sealed, which is really nice, that there's no way water can get in that way. But as this turns, right, this magnet goes around. And whenever this magnet lines up with this reed switch, we have the contact closes. So the way this works is that all it is doing is counting the number of ticks it gets per a certain amount of time. The details are not really too relevant, but if you get, say, 40 revolutions in a minute, by design, this thing, if it's turning at 40 revolutions per minute, that corresponds to a certain wind speed, say 20 kilometers an hour or something like that. It doesn't matter, but you calibrate that, and that's how that works. But why I'm interested, actually, is this board is clearly used for another product as well. There's actually a lot more in here than I expected. Here are the 4 photodiodes. that determine the direction from the wind vane. There's a chip on board here, or cob, it's a cob chip on board. Cob is the common term. You'll hear that a lot with modern LED lighting. They pretty much all do this. All chip on board means is that you don't have a separate package for the chip. You take the actual chip after it's manufactured and verified as working, place it directly on the PCB, the printed circuit board, and then you wire it up. And to protect everything, you put a blob of some material, an epoxy material, most likely, to protect everything. Now, I'm not too surprised that there's a chip in here. This here is the oscillator. When you see that, that tells you it is a 32.768 kilohertz crystal, and that produces a 32.768 kilohertz clock. And why is that important? Because 32.768 is very easily dividable through binary mechanisms to 1 pulse per second. So that's a clock crystal. If you open up the cheapest quartz, as it's called, quartz wristwatch, you'll see a crystal like that. They're dirt cheap. They cost nothing. They're mass manufactured. And inherently, because your circuit is only running at 18 kilohertz, it's low power. So something like this is very low power, which is good because it has a very, very long, I forgot how long the cable was, but like 50 feet or something. You do not want to draw a lot of current over that. Now, I was surprised when I first opened this. And why? Well, because of that. What is that? It's not connected to anything. Now, what that is that's a connection to an LCD panel. You'll hear of zebra strips. What it is you put these pads on your PCB, and then you use a zebra strip that is placed directly on these pads, and then on top of that you place your glass LCD panel. And the zebra strip is made out of several sandwich layers of resistive material, and they allow the signals to pass from the PCB to the LCD. LCDs, by their very nature, are very, very low current. So even though this zebra strip is a resistive material, it doesn't pass much current. It's more than enough to activate the LCD segments. So that's how you don't have to worry about alignment or anything like that. As long as your LCD is aligned properly with your PCB, the zebra strip has multiple contacts per pad, so everything lines up and the LCD works perfectly. Why is that interesting? There is no LCD. So clearly, this board, like normally you'd think, well, maybe those pads are for test purposes or something. No chance. You wouldn't have that many going directly from the chip on board. So what this is, this board must be used in another product. Perhaps a prior product, perhaps a parallel product, I don't know. Clearly, okay, so the wiring is meant for this board, so that's not unusual. There are positions on this board that are unpopulated. Here, it looks like there is a spot for a, what is that, a 14-pin chip, I guess? And there's another spot there for a little, well, 6-pin, a 6-pin chip, but there are only 5 pins. So that's interesting. So clearly this board is meant for this purpose, but is also, there must be another model where there's an LCD display, which is very odd. Because why would you need an LCD for a remote weather vane? I don't know. That's very interesting. This board was designed in 07, was manufactured in 07. That's what this 0703 means. Third week 07 is when it was probably manufactured or designed. I can't tell which. Yeah. All right. Well, you know what? That's why you open things up. Sometimes you get surprised. So what I might do is see what other products there were out there at the time. 2007, so a long time ago, 13 years now. And see if there was something that had a display. That's interesting. Very interesting. All right. Well, anyways, as always, that's all I got for now. Oh, just as an update, so this weather station actually came in two parts. This is the wind vane and an anemometer. Is that how you say it? I should have looked that up. It also came with a rain gauge. Now, like I said, the system isn't really. This was broken, and the display unit wasn't working great anymore. So I have deprecated it, but I have not replaced it because of the trait. But the rain sensor or the rain gauge still worked, and I didn't want to keep the whole thing. So what I'll probably do in another video is show you what I did with the rain gauge. I integrated it into my smart home system, actually. So I now have a rain gauge, and I did it through the cheapest, easiest way possible. I used a door contact. So anyways, that'll be another video, but for now, that's all I got. Have a great time, stay safe, and until next time.